Hello, future engineers. This is about centroids of volumes, areas, and arcs or lines. This is part 2. So we'll derive formulas for volumes, areas, and arc lines, and as well as the location of the centroids. Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is the video topic the on distributed forces, and first we'll have to familiar with the different locations of the centers of gravity or centroid of an object or a geometric figure, especially the common ones. This is to have an idea on how to place the equivalent weight or load of a given distributed load so that we can compute for the corresponding reaction components if it is a beam or other required elements such as shear and bending moment. So for this level 1 problem, we have to derive the location of the centroid of the triangle shown below. And we will call that xg, yg. So let's have a horizontal strip, and let's call the length of that strip as x, so that the thickness is dy, and our variable of integration is y, and it ranges from 0 to h. So the base is given b, and let's express x in terms of the variable y by similar triangle. So the distance of any point on this horizontal strip from the x-axis is just y. So y is just y sub c, the centroid of this strip, and therefore this is h minus y because the height is h. So area is integral of x dy, length of strip times dy, area of this rectangular strip, and it is from 0 to h. By similar triangles, x as to h minus y equals b as to h, so that means x is b over h times h, quantity h minus y. Substitute into the formula, area equals integral of b over h times quantity h minus y dy. So the integral, because this is constant, h dy is hy, then minus y squared over 2. So b over h times hy minus y squared over 2 from 0 to h. That means area is b over h squared minus h squared over 2 minus 0, the lower limit. Since h squared minus h squared over 2 is h squared over 2, cancel h, so area is bh over 2. Of course, you know the area of a triangle. Then area times barred y equals integral from c to h of y sub c dA, where y sub c is just y because every element of the horizontal strip is equidistant from the x-axis. Be it the left, the center, or the right, the distance is constant at y. So b over h barred y equals integral of y sub c, which is just y, times b over h minus y dy. So barred y therefore is 2 over h squared, out, after we cancel out b, of the integral of hy minus y squared after we distribute. So hy integral is hy squared over 2. Then y squared, the integral is y cubed over 3. Then times 2 over h squared. So this is h cubed over 2 minus h cubed over 3 minus lower limit 0. So we have 2 over h squared times h cubed over 6. Cancel out h squared. So barred y is h over 3. So 2 over h squared times h cubed over 6. So barred y is h over 3. So for barred x, this is the centroid. So call that x1. So x1 as to y equals b1 as to h. So that means x1 is b sub 1 over h times y. b1 is constant, it's given. So area barred x integral from 0 to h of x sub c dA, where Bar X, this is the centroid of the strip. So of course, this is a rectangular strip. So from the left, it is x over 2, then plus x sub 1. So x sub 1 plus x over 2. That's the value of x sub c. So x sub c is x sub 1 plus x over 2. So bar x sub c is b sub 1 over h, which is x 1 plus x over 2, or b over h minus y over 2. That's the value of x. Simplifying, x sub c is b sub 1 over hy plus b over 2h times h minus y. So area bh over 2, bar x equals integral from 0 to h of quantity b1, which is b1 over hy plus b over 2h times h minus y. This is x sub c times dA. This is this differential area, b over h minus y dy. So we cancel out b, then distribute. So bar x, h over 2 bar x equals b sub 1 over h square, because we have h here, times hy minus y square after we distribute y. Then because we cancel out b, there's no b anymore. So b over 2h square, distribute. So b over 2h square, h minus y square. So integrating, h over 2 bar x equals b1 over h square times quantity hy square over 2 minus y cube over 3 from 0 to h plus b over 2h square negative, because the integral of h minus y square is by power formula negative h minus y cube over 3 times 2, so over 6. And it's negative because the differential of h minus y is negative dy if you let h minus y as u. So that's the integral. Simplifying, h over 2 bar x equals b1 over h square times h cube over 6 minus b over 6h square times 0 minus h quantity cube, because when we substitute the upper limit, h minus h is 0 cube, then lower limit h minus 0, so minus h cube. Simplifying further, h over 2 bar x equals b1 h over 6 minus b, or plus b h over 6. Cross multiply and simplify, so that means bar x is x sub g equals b1 over 3 plus b over 3. So that's the value of x sub z, or bar x. If you check with our formula, remember that the centroid of a triangle in terms of its coordinates would be 1/3 the average of 0. This is 0. b1 plus b, which checks here 1/3 of b1 plus b. If you check y sub g, the y coordinate of this vertex is h, here 0, 0, so 1/3 of quantity h plus 0 is h over 3. So that checks. In general, if the orientation of the triangle, right triangle specifically, would be this, then bar x would be 1/3 of b. So this distance is 1/3 of b. And bar y would be 1/3 of h. So you have to familiar with that. And in this, especially in this general orientation of the triangle. Derive the location of the centroid of the sector shown below. So this is the sector, and the angle, central angle, is 2 theta. The axis of symmetry is the y-axis, therefore the centroid lies on the y-axis. So we only need bar y. Bar x is 0. So this is our strip. We can treat this as a sector or a triangle. First, a sector. Remember that the area of the sector is 1/2 r square radius square times central angle. If the central angle is differential alpha, this should be alpha from the y-axis. So area equals from negative theta to positive theta. From this side negative theta to positive theta. dA, where dA is 1/2 r square differential alpha, the area of a sector element, or we treat this as a triangle, area 1/2 base times height, where the base is RD alpha, 1/2 of RD alpha times the height, which is also R. So that's why it is also 1/2 r square the alpha. So 1/2 r square differential alpha, we can treat this as simply area of the sector element, 1/2 radius square times differential angle differential alpha. The other treatment is we can approximate this as a triangle with sides R and R and central angle differential alpha, or base RD alpha and height R. So the area of a triangle is 1/2 base times height, 1/2 of RD alpha. If you break R square into RR, so RD alpha, 1/2 of RD alpha times height, which is also R. So there are two interpretations of that area. The direct interpretation and treating the sector element, this differential sector, as a triangle. So area is 1/2 r square. Integral of differential alpha is alpha, of course, of negative theta to theta. So area is r square over 2 times quantity theta minus negative theta. So 2 theta, so our area is r square theta. So in general, area of a sector is 1/2 r square times central angle. So if you apply 1/2 r square times 2 theta, the central angle, it reduces to that. So area times barred y. So if this is alpha and this is the centroid, from this center to that centroid, because we treat this as a triangle, if the distance of the centroid from the triangle to its base is 1/3 of its height, then this is 2/3 of its height. The height is the radius of this sector. That's the height. So this is 2/3 of r, where r is the height. And therefore, this y sub c, imagine this is a right triangle, and the hypotenuse is 2r over 3. In terms of alpha, this is hypotenuse 2/3 of cosine of alpha. So y sub c is 2/3 r of cosine of alpha. So area barred y equals integral of y sub c differential area. The area is r square theta, then barred y integral from negative theta to theta of 2/3 r cosine alpha times differential area 1/2 r square differential alpha. Cancel r square, so theta barred y equals 1/3 of r, then integral from negative theta to theta of cosine alpha differential alpha. The integral of cosine alpha differential alpha is sine alpha. So barred y, theta barred y is r over 3 sine alpha from negative theta to theta. So barred y is r over 3 quantity sine theta minus negative sine of negative theta. So area equals 2/3 sine 2r sine theta over 3 theta. So barred y, or y sub g, is 2r sine theta over 3 theta, which verifies the location of the centroid of a sector element. Then if the sector is a semicircle, alpha here, theta here is 180 over 2, or 90 degrees, or pi over 2. So therefore this is 2r sine of 90, which is 1 over 3 times pi over 2, so 4/3, 4r over 3 pi. So that's the result. 2/3 sine of 90 degrees over 3 times pi over 2. That would be 4r over 3 pi. Then if we have a semicircle, this is 2r sine, the angle, central angle is 90, so therefore theta for that is 45, or pi over 4. So substitute into the formula, 2r sine 45 or 3 pi over 4. It is 8r over 3 pi sine 45, this inclined distance. but we are looking for barred x and barred y. So therefore, x sub g is hypotenuse 8 over 3 pi sine 45 cosine 45, and y sub g is 8r over 3 pi sine 45 sine 45. Since sine 45 degrees and cosine 45 degrees are equal, and the product of sine 45 and cosine 45 degrees is 1/2, therefore it reduces to 4r over 3 pi. Similarly, for y sub g, it is also 4r over 3 pi. So that's it. X sub g equals y sub g equals 4r over 3 pi for quarter. Level 3, derive the location of the centroid of the arc of a sector shown below. So this is the arc of the sector, and the angle is bisected by the y-axis. By symmetry, the centroid would lie on the y-axis. Therefore, barred x is 0. So we only need barred y or yg. So we have a strip, and the differential angle here is differential alpha. The length of the differential arc, therefore, is radius times central angle r d alpha. So this is considered as a point, and this angle is alpha. Therefore, if you imagine a right triangle with hypotenuse r, then this is r cosine of alpha. So y sub c is y equals r cosine of alpha. First, for the arc length, differential s or s is integral of r d alpha from negative theta to positive theta, where ds is r d alpha. So since r is constant, the integral of differential alpha is alpha from negative pi to negative theta to theta. So s therefore is r times theta minus negative of theta. So s is r times 2 theta or 2r theta. Then s times barred y or y sub g is integral of y sub c differential s, where y sub c is r cosine of alpha. So r times 2 theta barred y equals integral from negative theta to theta of r cosine of alpha times differential s, which is r d alpha. Cancelling out r, so 2 theta barred y equals r integral of cosine alpha differential alpha. The integral of cosine alpha is sine of alpha. So 2 theta barred y equals r sine alpha from negative theta to theta. So 2 theta barred y is r quantity sine of theta minus sine of negative theta. From trigonometry, that's why I started the playlist with ground zero. So negative sine of negative theta is negative sine theta. Therefore, this becomes positive, and the entire value of the expression is 2 sine theta. So 2 barred y equals 2r sine theta. Cancelling out 2, so barred y, which is yg, is r sine theta over theta, which verifies the formula in the background or in the first part of this playlist. In the first part, this is part 2, remember. So for semicircular arc, the centroid is here, and the value of theta is 90 degrees. That's 90, or pi over 2. So we substitute sine of pi over 2 or sine of 90, the same one. And in the denominator, theta should be pi over 2. So barred y or yg is barred y equals r sine of 90 degrees over pi over 2. So that's why it is 2r over pi. Similarly, for quarter circle, barred x sub g is y sub g, and it is equal to 2r over pi because the centroid of the left half is here, same level as the centroid of the semicircular arc, as well as the centroid of the right half. So barred x sub g equals y sub g equals 2r over pi. So that's it for this problem. Level 4, derive the formula for the volume and location of the centroid of a pyramid. So we have here a pyramid. Then for the location of the centroid, we also extend it to right circular cone. So let's consider a slab or strip. Then the distance from vertex to any point on this slab is constant at y because that's a horizontal slab. So we'll just call that y, and the centroid lies also there. So y is automatic y sub c. So this is h, capital H minus y, dy, thickness. And the area of the rectangular slab is, let's denote it area y because it varies with y. Then volume equals integral of differential volume. The differential volume is the area of this rectangular slab. Of course, the area of the rectangular slab is area of the rectangle, top area, area y times thickness dy. So we must express area sub y in terms of y by similar solids. So area y, because this is square units, then it should be as to y square. So that y square would be in square units also. So that's the principle in similar solids. Because this solid here, which is a pyramid, is the same as that big pyramid. So area y as to the square of y, y square equals area as to big H square. So that means area y is area over H square times y square. So volume therefore equals integral from 0 to h of area over H square, y square, then differential volume area over H square times y square area y dy. So area over H square constant, integral of y square dy is y cube over 3. So y cube over 3 from 0 to big H. So therefore volume is area over H square quantity area cube H cube over y minus lower limit 0. Therefore volume is area H over 3. So it verifies the volume in general. Then volume times barred y equals integral of y sub c differential volume. So y sub c is just y. And therefore area H over 3 barred y equals integral of from 0 to h of y sub c, which is just y, and differential volume, which is this area over H square y square dy. So if we factor out area, we can cancel area, by the way. And if we simplify the right side, that's integral from 0 to h of y cubed dy, which is y to the 4th over 4. So canceling out area, so h over 3 left here equals times barred y equals 1 over h square. Then integral of y cubed dy is y to the 4th over 4 from 0 to h. So barred y therefore is 3 over 4 h cube, h times h square, so h cube, then 3 cross multiply from h, so we have upper limit h to the 4th minus 0 to the 4th. This is h to the 4th. Cancel out h cube, so 3/4. So that verifies the formula in the beginning of this playlist for distributed forces, centroids, so volumes, areas, and lines or arcs. So we extend that to right circular cone. The volume is area h over 3. The area of the base of the cone is area of a circle, pi r square. The height is big H, then divide by 3. So for the centroid location, this is 3/4 of big H, and therefore from the base, 1/4 of big H. So level 5, derive the volume of the location of the centroid of a hemisphere. So that's the sphere. For the solution, let's have a horizontal strip. Then the distance of every element of the top surface, which is a circle, from the x-axis is constant at y. Then the axis of symmetry is y, therefore the centroid of the hemisphere lies on the y-axis. So barred x is 0. That's why we only need barred y. So later on, y is just y sub c. The thickness of the strip is dy as shown, so the variable of integration is y. Therefore, volume is integral of pi radius of the circle x square, or area of the circle, thickness dy. So if this is y, then x square equals r square minus y square by Pythagoras theorem, or by equation of circle with center at the origin, x square plus y square equals y square. So volume equals integral of dv, and dv is the area of this circular slab, which is pi radius square pi x square dy. Since x square is big R square minus y square, and pi is constant, so if we integrate, we have pi outside, quantity r square dy, so r square y, the integral, minus y cube over 3. From 0 to r, so we have volume equals pi, quantity r cube minus r cube over 3, minus substitute lower limit 0. So this is 2/3, so volume is 2/3 pi r cube for a hemisphere. For the whole sphere, we call that sphere, times 2, so 4/3 pi r cube in terms of the diameter, pi over 6 diameter cube. So that's it for that volume. For the location of the centroid, volume barred y equals integral of y sub c dv, where y sub c is just y, because every element of the horizontal slab of this circular plate is equidistant from the y-axis, so we just call it y. So 2/3 r cube, 2/3 pi r cube barred y equals integral of y. Differential volume is pi, quantity r square minus y square dy. So if we cancel out pi, then we have 2/3 r cube barred y equals integral of r square y minus y cube. So the integral of the first term, r square y, is r square y square over 2. Then integral of y cube is, so we have minus y to the fourth over 4 from 0 to r. Since 2/3 r cube barred y equals r to the fourth over 2 minus r to the fourth over 4. These are like terms, so 1/2 minus 1/4 is 1/4. So we have 2/3 r cube equal barred y equals 1/4 of r to the fourth. Canceling out r cube, so this is r over 4, then cross multiply 3r over 2 times 4, so 3/8 of r. That's the location of the centroid of a hemisphere from its base, which is circular. Now for a spherical segment of one base, this is a spherical segment of one base. If the thickness of, or the height of the spherical segment of one base is h, then this is radius minus h. So volume would be integral from this level, which is r minus small h. Small h is given as well as big R. So from this level, this is r minus small h, and from x-axis to that top surface is r. So that's why the lower limit r minus small h, the upper limit is big H. And this is differential volume from here. So distribute. Volume equals pi. The first term is r square y. The second term is y to the 3 over 3 from r minus h to r. So pi, quantity r cube, or r square r, minus r cube over 3 minus lower limit r square times r minus h, minus upper limit r. This is the integral negative y cube over 3, so negative of r minus h cube over 3. So we have r cube, and we also have minus r cube, so out, and we have r square h, positive r square h, and positive integral of r minus h quantity cube over 3. So volume equals pi quantity negative r cube over 3 plus r square h. This r cube over negative r cube over 3 is this term here. Then r cube minus r cube is out. Then we have negative r squared times negative h r square h. So that is the simplification of these first two terms, and after we simplify the third term and distribute negative. So what is left is this, which is positive negative of negative positive r minus h cube over 3. The expansion of r minus h quantity cube is cube of the first, so cube of r, plus 3 times the square of r times second term. So the square of r is 3, square of r, sorry, the square of r is r square. So we have the expansion here, r cube, first term cube, minus 3 times the square of the first, so 3 times r square, times the second, which is negative h. So that's why you have negative h over 3. Then for the third term, 3 times the first, then square of second, so that's why plus 3 times first, then square of the second. Then the last term is cube of the second term, so negative h quantity cube is negative h cube. Substitute and take note that we have negative r cube over 3, we have positive r cube over 3, so that would be out. So negative r cube over 3 plus r square h plus r cube over 3 minus r square h, then plus 3, cancel 3, so r h square, then minus negative h square over 3, so times 3. So we have the cube of the second rather. So we eliminate these terms, first 4 terms out. What is left is rh square minus h cube over 3. So volume is pi r square h square r h square rather minus h cube over 3. So factor out h square over 3, so pi h square over 3, quantity 3r minus h. So that's the volume of a spherical segment, right? With one base, pi h square over 3, quantity 3r minus h. So I call this level 5.8, derive the y coordinate of the centroid of the nth degree curve shown below. We already derived the location of the centroid of this nth degree curve from the y-axis 3/4 of a, 3/4 of b, then from this vertical leg 1/4 of b, or in general b over n plus 2, if you can remember. So b over n plus 2. So therefore this is n plus 1. This is b over n plus 2. So from the y-axis, barred x or x sub c is b minus b over n plus 2. So it should be simplified. So we have vertical strip, the height is y because the lower y is 0, which is the x-axis. The equation of the x-axis, by the way, is y equals 0, while the equation of the y-axis is x equals 0. I hope you know that already. So the thickness is dx, this is x. The x, therefore, is the variable of integration. The location of centroid is at half of the rectangle. So y sub c is 1/2 of y. First, for the area. So area, by the way, the area is bh over n plus 1. So area yg equals integral 0 to b y sub c dA. So there's no need to compute for the area because I already derived that. So bh over n plus 1 yg equals integral of y sub c, which is y over 2. Then dA is is the area of the strip, which is height y thickness dx. So ph over n plus 1 yg equals 1/2 integral of y squared dx, where y squared over y is kx to the n. So when y is h, x is b, so y equals kx to the n, so h equals kb to the n. So that means k is h over b to the n. Substitute here. So this is y, h over b to the n, k times x to the n. So substitute in this formula, bh over n plus 1 yg equals 1/2 integral of y squared, so integral of quantity h over b to the n, x to the n, quantity squared dx. So simplifying, bh over n plus 1 yg equals 1/2 h squared over 2b to the 2n plus 1 integral 0 to b of x to the 2n dx. Cancel out h, so we have h left here. So 1 over n plus 1 yg equals h over 2b to the 2n plus 1. The integral of x to the 2n is x to the 2n plus 1 over 2n plus 1. Then we have b to the 2n plus 1 because we cross multiply this. B to the 2n times b is b to the 2n plus 1. So after we integrate, this is the result. Substitute x, upper limit b, lower limit 0. So 1 over n plus 1 yg equals h over 2 b to the 2n, then b to the 2n plus 1 over 2n plus 1. Cancelling out b to the 2n. Then yg is n plus 1 over 2 quantity 2n plus 1. So that's the formula for yg or y.